the 2012 ordinary level, the third video on this 2012 ordinary level, and it's paper 2, and this is the 12th question, okay? The diagram below shows an angle A in a right angle triangle. Now remember, right angle triangle, you're going to be going for SO, Ka, Toa, okay? Obey sine, cosine, tan, okay? Now, indicate which side is adjacent, which side is opposite in relation to the angle A, in relation to the angle A, and which side is the hypotenuse. Hypotenuse is always the longest side. So the side that looks the longest is the hypotenuse. Okay. Now, always imagine the angle like an eyeball. Which side does the eyeball look at? It looks at opposite. So remember that. You always look at things that are opposite you. So imagine the angle like an eyeball, and that will always give the opposite side. Then by process of elimination, the third side has to be the adjacent. Okay? Now, what we're going to have next is find the fill in the appropriate ratios in the table below. What a trigonometric ratio is sine, cos, and tan. So what you're going to need to do is you need to put down your rhyme, SOH, so, ka, toa. Now, you're just going to make a quick list. This one has opposite and hypotenuse, which is O and H together. So what this means is that it's going to be sine A. Cos A, ka, is adjacent divided by hypotenuse. So this one here is going to be adjacent divided by hypotenuse. Okay. And finally, opposite over adjacent would be toa, O and A. So opposite over adjacent will be tan A. In the right angled triangle below, right angled triangle, once again remember, so katoa applies because it's a right angled triangle. B equals 35 degrees, and the opposite side is 12 centimeters. Find the length of the hypotenuse correct to the nearest centimeter. Okay, B is 35 degrees. You want to find out the length of the hypotenuse. Let's call it X. Okay, so we want to find out the length of this side here, from here to here, and here down to here. Okay, so what we got to remember is we're looking for the hypotenuse. So what we have here is H. We know the opposite, because look where the eyeball always looks at the opposite. So we're going to use O and H. And therefore we're going to use sine. Sine of 35 degrees, because it's sine 35 degrees, always equals opposite over hypotenuse. Opposite is 12 centimeters. The hypotenuse is X. Now the trick is we need to get X on its own. X is division on the right hand side of the equals. When you move it over to the left, it's going to become multiplication. So it's X multiplied by sine 35 degrees equals 12. Now, what you need to get rid of is you need to get X on its own. So you got to bring the sine and the 35 over the other side. Two things to remember about sine. Sine and the 35 are linked together. They cannot be separated, okay? Now, in order to bring it over to your side, X is currently being multiplied by sine 35, which means when it goes over the other side, it's now going to be in division. So X equals 12 divided by sine 35. And 12 divided by sine 35 is going to be 20.92. So 20.92. Okay? Now, reread the question. It wants it correct to the nearest centimeter. So it's 20.92 centimeters, round up to 21 centimeters. And now you're on the next question. Sean is making a kilometer using a protractor, a straw, a piece of thread, and a piece of plasticine used as a weight. He stands 10 meters from a tree, uses clinometer to measure the angle of elevation to the top of the tree as shown. Sean is 1.7 meters high. So we see Sean here, and he measures this angle, and he's trying to figure out what the height of the tree is. Remember, this is a right angle triangle because it's straight across and straight up. The adjacent side of this triangle is 10 meters long because it says he's 10 meters away from the tree, and what we're looking to do is looking to find the height of the triangle, of the tree, from here to here. Okay, now what we got to remember is the kilometer. We got to measure this angle. So remember, protractors go up in 10, 20, 30, 40, 50, 60, 70, 80, and 90. Now remember, the angle he makes when looking at it is going to be this angle here. It's halfway between 60 and 70. It's going to be 65 degrees, okay? So the first answer is find the angle of elevation using the kilometer above. It's going to be 65 degrees. Okay. Next one. Calculate the height h as shown in the diagram. Give your answer correct to 2 decimal places. Now, what we know about what just happened here was there's a right angle triangle. Okay. This here is the tree, or part of the tree. And then there's a certain part of the tree underneath his eyesight. Sean is here. Now what we know is that this is 65 degrees, and we know this here is 10 meters. And what we're looking to do is we're looking to find the height h as shown. So let's just verify that. We're looking to find this here is 65 degrees. H is the bottom, and we're looking to find the height. Okay, so what we're going to do here is basically we're going to do SOHCAHTOA again, and we're going to figure out which one we need. Now, what we're looking to find out is 65 degrees points at the H. H is opposite, and the 10 meters is adjacent, so opposite and adjacent. Therefore, we must use tan. Tan 65 equals opposite divided by adjacent, which is going to be h divided by 10. We need to find out what h is on its own. The 10 is divided on the right, which means when it moves to the left, it's going to be multiplied by 10. 10 tan 65 equals h. Now remember, it wants this answer correct to 2 decimal places. So it's going to be 10 tan 65, and that's going to give me 21.445 meters. Remember, 45 will get rounded up to 50, so it's going to be 21.450 meters. We don't need the 0, so we just want 21.45 meters. Next thing, find the total height of the tree. Now the total height of the tree can basically mean is, we know that this is 21.45 meters, and we know Sean's height at eye level is 1.75 meters. So it's going to be 21.45 plus 1.75 to get the total height. So it's going to be 21.45 meters plus 1.75 meters, and that's going to equal 21.45 plus 1.75, and what we'll get here is 23.2 meters. Okay. Another student uses the same method as Sean and finds the height of the tree to be 23.1. Now as you can see, it's just a small bit out. Sean did not get this answer. Give one possible reason why the answer might be different. Now remember, Sean gets this reading by using his eyesight. Right? If another kid came along who's not Sean and did the same experiment, he might have read a slightly different angle. He could have read like 64 or 65 degrees, for instance, okay? So what you can say is there could have been a human error in the difference of getting the angles. Okay? So the other student may have made an error in reading the clinometer. And the other thing might be is that if you add on 1.75 meters, remember that's Sean's height. And you can say the student might not, another reason is the student might be a different height. The student might be a different height. Okay. Next question. Write down the coordinates of A and B on the diagram. Okay, so A is 1 across 1 up, which is 1, 1. B is 11 across 1 up. So 11 across 1 up. Points A and B in the diagram. Mark the point D on the diagram. D is 6, 8. 6 across, 8 into the air. Is going to get me 6 across, 8 into the air. Will get me here. Okay. Next one. 6 across, 8 into the air. This is 6, 8. Now, mark the point D, and D is 6, 8 on the diagram. Done. Find the coordinates of C, the midpoint of A and B. Let's measure the length of A to B. We can see it's a straight line. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 units long. The halfway point is going to be 5 units from the beginning. So 1, 2, 3, 4, 5. And there's your midpoint right there. Okay. Now, find the coordinates to see the midpoint of AB. Now, another way of doing this would have been to use the midpoint formula. We can see that the point is 6, 1. 6 across 1 here. Another way of doing this would have been to do the midpoint formula of x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Please remember this formula is a midpoint, so you need two answers, one in the first part and one in the second part. Call A, remember A is 1, 1. So A is going to be x1, y1. B is 11, 1, which can be x2, y2. And what will happen here is we put them into the formulas, and what we'll get is x value will be 1 plus 11 divided by 2. The y value will be 1 plus 1 divided by 2. And the answer will be 12 over 2, because 11 plus 1 is 12. So that'll get me 12 over 2. And 1 plus 1 over 2 is going to be 2 over 2. And what I'll get next is 12 divided by 2 is 6. 2 divided by 2 is 1. 6, 1. And we can see it's the same answer, okay? Next thing you want me to do is join A to D and join B to D. Okay, so join A to D and join B to D and join C to D. So what it wants me to do is this, and this is part C. So it wants me to join A to D, like so. It wants me to join B to D, like so. And it wants me to join C to D. So this is what we're going to have here, okay? Now, that's done, okay? Use the distance formula to find out if AD, to find AD and BD. So AD and BD. So let's see what AD and BD is. Okay, so we're going to have to use the distance formula. And for the distance formula, you're going to check this in your tables. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. And the points A, B, we need to put down the points A, B, C, and D. So A is the point 1, 1. So A is 1, 1. D is 6, 8. B is 11, 1. And D, once again, is 6, 8. Now, first of all, I want to get the length of AD. So the distance is the length of AD. So what I need to do is I need to put down x1, y1 as A, x2, y2 as B. It doesn't matter if D is x1, y1 and A is x2, y2. You'll still get the same answer, okay? So what you have here is the square root of, what you're going to get here is 6 minus 1 squared plus 8 minus 1 squared. Just enter this into your calculator exactly as it looks, okay? So enter it in exactly as it looks. And what you're going to get, the length of AD, is going to equal root 74. And root 74, press the change button in your calculator, is going to be 8.6. Now we got to do BD. Let's find out what BD is. And BD, once again, is going to be the square root of x2 minus x1. So this time we'll call B is going to be x1, y1, and D is going to be x2, y2, because we're now doing BD. Okay, so x2 is going to be 6 minus 11 squared plus 8 minus 1 squared. Once again, type all of this into your calculator, everything in the pink box here into the calculator, and what you're going to get is that the length of BD is root 74 and equals 8.6. Now what you've now learned is that this side here is the same length as this side here. Therefore this angle here must be the same size as this angle here. It's basically an isosceles triangle because both sides are the same length. Remember, a isosceles triangle is a triangle that two sides are the same length in. Okay? What type of triangle is ABD? You said isosceles triangle. Reason, two sides in the triangle are the same length. Okay. State whether the triangles ACD and BCD are congruent. Give reasons for your answers. Okay, now remember what congruent means. Congruent basically means prove they're the same. So prove it's either SSS, all the sides are equal, side angle side is equal. Now remember what side angle side means. Side angle side means you get two sides are the same length, and you get the angle in between them is the same. You can use angle side angle, and angle side angle basically means you need to prove two angles are the same and the side in between them are the same. So you need to prove that these two angles are similar to the ones in the other triangle, and you need to have the side in between them as the same. Or we can use RHS, which is used for right angle triangles, where we know the hypotenuse of the right angles are the same and we know that one other side is the same. So let's see which one we're going to use for this triangle. Okay, so what we can say right away is that this side is equal. We know this side, so we know that AD is equal to AD equals BD. We also know that AC has a length of 5. And we know that CB also has a length of 5. And we know that this side has to be the same because it's the common side in between. So, when we look at this triangle, what we can say is the following. We can just draw a quick sketch of it here. Okay, so just something like this, okay? and we know that it's down the middle. Okay, and what we have here is A, D, B, and C. Right. State whether yes, they are congruent. Is the answer. Now the reason they're looking for is you need to compare both triangles to each other. So what you can say is AD equals DB, and that gets you one side. The next reason is AC equals CB. Just keep it in capitals. AC equals CB, and that's another side. And then finally the third side is DC equals DC. Now remember, on each side, the one on this side are sides belonging to the triangle ACD, and on the right hand side are sides belonging to the triangle BCD. Okay, and that's your reason why they're congruent. Okay, next question. The height of a watercress seedling over 6 days is shown on the diagram above. So what you imagine is you have a piece of dirt here, and you have the seed growing up, growing out, okay, day after day after day. And what's happening is it's getting bigger and bigger, and what we're doing is we're measuring the height of it above the ground, okay? Now, what we can the plant grows steadily between A and B, but does not grow during 2 periods. Identify these 2 periods from the graph. So what we can see is on day 0, it has no height. So after day 1, it has a height of 0.5, and after day 2, it has a height of 1 centimeter. However, it stops growing in between B and C. So the first period it doesn't stop growing to is B to C, and the second period is going to be D to E. Okay, D to E. Find the slope of AB. So I need to find the slope of AB. A to B. Now this can be done 2 ways. The first way is you can do what's called rise over run. So slope equals rise over run. Now the run is how far it goes to the right. Okay, so it goes 2 to the right and then 1 into the air. Okay, so because it's to the right, the run is positive, and if it goes up, the rise is positive. So the slope is a half. Okay. A second way of doing this would be to, instead of using rise over run, you can use the slope formula and identify your 2 points. So the slope formula is given to you in your table. So this point here, point A is 0, 0. Point B is 2, 1. So we can say is B is x2, y2, A is x1, y1. And what you can say is the slope formula equals y2 minus y1 over x2 minus x1. And what this would get you here is y2 is 1 minus 0 divided by x2, 2 minus 0. Put that into your calculator and it'll also give you a half. So we can see it adds a half. Now we need to find the slope of C to D. C to D, once again, we're going to do rise over run. It goes 1 to the right and 1 into the air. So rise over run. The rise is 1. The rise goes 1 up in the air. The run goes 1 to the right. So it's going to be 1 over 1. Okay. We could also do the slope formula for this. To do the slope formula for this equation, what we could do is we could say that this here is 3, 1. D is going to be 4, 1.5. Okay, once again, y2, x2, x1, y1. And what we can do is we can get the slope of this one here. So y2 is 1.5. y1 minus y1, which is 1, divided by y2 minus y1 divided by, sorry guys, excuse me, the rise over run, if I just do this again, sorry, the rise over run, it's 1 across and it's 0.5 into the air. So it would have been 0.5 divided by 1 for the rise over run. You can put that into your calculator and what you'd get would be a half. So excuse me, so sometimes it's a good idea to do it two ways, okay? So it would have been a half using rise over run. Now finally back onto my formula. I'm on x2 minus x1. x2 being 4, x1 being 3, so 4 minus 3, and you're going to get 0.5 over 1. Put that into your calculator and it will also turn out to be a half. Okay, so both slopes are a half. We can actually see they're pretty much parallel. They are parallel lines to each other, so they should have the same slope. Okay, question D. Janet says that the seedling grows at the same rates in the two growing periods. Do you agree with Janet? Give a reason for an answer. Yes. Same rate, it means same slope. Okay, let's go back for a minute. A to B grows 1 centimeter over 2 days. So let's have a quick look at this here, guys. And it's going to be from A to B. It's going to be 1 centimeter. It grows 1 centimeter in 2 days. So A to B is 1 centimeter in 2 days, or half a centimeter in 1 day. Okay, let's look at C to D now. The time is 1, so it's half a centimeter in 1 day because it grows up a half a centimeter in 1 day. So half a centimeter in 1 day. Okay, so let's give a good reason for this. Yes, both growing periods have the same slope. The same slope. And if you're looking for a more concrete answer, both periods have a growth rate or a growth rate of 0.5, half a centimeter a day. Next one. Describe the growth of the seedling over the 6 days. So the growth of the seedling over the 6 days. Okay, let's start off. In days 1 and 2, it grows steadily from 0 to 1 centimeter. So we can do it this way. In days 1 and 2, the seedling grows steadily from 0 centimeters to 1 centimeter. In days 2 to 3, it doesn't grow at all. In days 2 to 3, it doesn't grow at all. Doesn't grow at all. Next one is in day 3 to 4. it grows steadily again. It grows steadily from. Now, what steadily means is that it grows constantly, right? It doesn't change around. So it grows steadily from at the start of days 3 to 4. It starts at 1 centimeter and ends up at 1.5 centimeters. Okay. One centimeter to 1.5 centimeters. And finally, in days 4 to 6, it doesn't grow at all. It doesn't grow at all. Okay. Now, that concludes the end of the 2012 paper.